I'm Janno Tomingas, and I will be talking a little bit about what my team is doing to keep our services in Azure secure end-to-end, and some of the things that we changed in the way we approach security, compliance, sometimes even reliability alongside the move to Azure. So I included some of the very basics as well, because I think touching upon the essential is required. And then hopefully there will be at least a few things that are new to you. So a little bit about the agenda. I will give a short overview about myself, about my team, what we do, what our service is. And then I've tried to spread the points into somewhat logical categories to tackle one by one. So the main source of my experience with these topics has been our work on the Azure Service Fabric deployments. So if you're using something that has a bit higher abstraction over the hardware, maybe some of the things don't apply to your services, or maybe these things are not supported for your use cases. So about myself, I have been working at Microsoft for just a bit over 5 years. I joined as a mid-level engineer and have taken several career steps, first to become a senior engineer and now to a senior engineering manager. And I could say that probably the biggest effort so far for me has been to take part and sometimes even lead our migration from bare metal to Azure. The team consists of 11 people, including me, and the core of our business is providing a stun and turn service for Skype, Teams, and Azure Communication Services. So what those protocols do, first of all, the most important part, which is present in every call scenario, is that we allow for public IP discovery for clients. So if you're calling from a private network, you usually have a private IP address, and to be able to communicate your public address, you will come to us and we will tell you. The other thing about the turn part is that whenever a direct media connectivity path cannot be established between two clients. So let's say you have maybe restrictive firewall conditions or some NAT configuration that doesn't allow for that, you can forward all your media packets through us. That includes audio, video, screen sharing. And with ACS also we will be doing some data transfer as well. To simplify our lives a little bit, we have actually spread this out between 3 sub-services. So of course the core, the relay service, a binary written in C++, supported in C# libraries. Then we have, kind of for legacy reasons, a separate authentication token provider, and for very specific use cases, an Anycast routing-based load balancer. So if you're interested in that topic, I can talk about that outside. So about the scale, currently we're deployed to 20 plus Azure data centers. I'm saying 20 plus because the count is actually changing all the time. So sometimes we evacuate some data centers, sometimes we need to add some more, so usually it's a bit fluctuating, but in general the tendency is to increase. And core count globally is somewhere around 60,000 cores. So first of all, I will touch upon the security aspects of code and binaries before, during, and after deployment, which is something that we have taken great care of to get mostly right, I would say. So essentials, of course, take your library updates, take your security updates. If you don't protect your code, nobody else can do anything about that. Then, of course, the PR process itself. Before we migrated to Azure, I guess it kind of coincides timeline-wise. We had a process where if someone approved your pull request, they could approve it with suggestions. And with those suggestions came the option that you could push changes and then merge to master. Of course, if you allow this, then you can push any code and then merge to master, right? So do you really know what's running in your servers if you allow for this? Well, we turned it off. Then, secondly, credential scanning. We didn't have many credentials in code, but we had to remove them, of course, because if you deploy anything, then Then if they come from source code, of course, that's very convenient. But at the same time, your source code will probably be read by external parties. With recent cyber attacks to many companies, big companies usually report those. Smaller companies maybe don't even know they have been attacked. When an attacker reads those credentials, they will be able to access your services. Doesn't matter where you're deployed. So another thing, rotate those, remove those from code, substitute those with reading from secure storage like Azure Key Vault, and when substituting them within configuration files, always encrypt them as well, because the signed packages, or well, packages themselves are usually stored somewhere as well that could be read. So I would say these are probably the most important things that we changed about that. Another thing, the binary validation part and signing. During the build process, we also sign our binaries now. What that enables us to do is, for production machines, we actually check that whatever we run has been built by our build system. So previously, I was not aware that this was a required practice, but now to think about it a little bit further, you could build anything on your computer, craft a deployment package, and then deploy it to cloud. The cloud will not tell you that this is wrong. Your coworkers probably will not notice. So that's also another consideration. And to even validate the packages, during some scenarios, we actually generate the manifest of all the files in the package and sign this manifest file. So if anybody tampers with the package, we will know, and it will not get deployed. Sorry, the glass is in a little bit of an inconvenient place. So, going a little bit further into the setup of infra and machines. Well, of course, the basics again, system updates. Your operating system comes with vulnerabilities. If you don't take those updates, if you turn them off, well, again, you will get probably attacked at some point. The same thing with network security groups and firewalls. So set them up to allow only for the traffic you need. So for us, we have disabled everything except the things strictly necessary. So you will probably mitigate many exploits for services that have open ports. Historically, with Microsoft products, I think there have been some NTP vulnerabilities, RDP vulnerabilities, so if you block them out, they cannot be accessed. Another kind of a fun story from my experience was that when we added a new firewall rule, it actually broke one of our dependencies. So we were deploying it, suddenly our application was unable to run. And we contacted the authors of the dependency and told them, hey, we closed this flow and now it's not working. And they said, that's impossible, we don't need this flow. Then we actually looked at the traces and showed them, yes, you depend on this flow. And they weren't aware that they were depending on this. So something we learned. Sometimes even your library authors don't know, and if you know, that's all the better, right? Going forward, secret and certificate management. What we did, from our point of view, definitely, or usually I would say maybe even the basics, of course. We were previously storing secrets in a SharePoint page that was controlled by having access to a team group. So if you look at the group members, there are plenty of people who have left the company. There are people who are not part of the team anymore, working in the company. Well, that's a no-go. We moved to Azure Key Vaults. Now, having Azure Key Vaults actually benefited us immensely in terms of having the option to automatically rotate and put to use secrets and certificates. So whenever you deploy, you read those values from the Key Vault. You can easily substitute them, and at runtime or during deployment time, it's your choice. But we also tackled with resiliency. With COVID times, we had high increases of traffic, and then some Azure data centers just gave out. The uplinks were not strong enough, and suddenly we were unable to access some of our Key Vaults. So of course, Key Vault resiliency became a big topic for us. To support having multiple Key Vaults, we actually had to move to serial subject name and issuer validation for certificates, which means that we can have 20, 50, however many key vaults, and each of them can have a certificate with the same subject name, but they are entirely different certificates, auto-renewing at different cycles, and then taken into use automatically. So first of all, fully automated certificate rotation saves you a lot of time. And then if that's already implemented, then a single Azure location or whatever cloud you're using falling down will just be localized. Anything else will be self-sufficient. You will be able to run without any issues, without your customers maybe even noticing if it happens to be a lucky time. Then on the authentication flows, I would stop for quite a short time. So first of all, service-to-service authentication flows, for us, what that meant was we were moving away from MTLS-based flows, which is just having a certificate authenticating to a service, but also within Azure, we have made several improvements. We used to have a service principal and a certificate to log in with it, but now we're using managed identities instead, so again, less effort from our side. And operator to service is kind of a feat of engineering. I would even say what we managed to do is Service Fabric places some expectations on you that you will be able to authenticate with a certificate. But somehow, one of my smart engineers, with help from other Microsoft engineers as well, managed to turn this entirely off, and now we're also using a service principal to access it. When you want to manage the service, you will have to log in with your own account, and then the service principal will be able to impersonate you, and you don't have direct access to anything, and no certificates, passwords can be used to manage. And on the machine, except for, of course, validating that we're running the correct binaries, we are monitoring for unexpected activity with an intrusion detection system. We know that it works because pretty much every time we log on to the machines to do some unexpected work that we don't have the tools available for, we get an alert. Someone was running weird PowerShell commands. There's unexpected network activity. So these things definitely work and will help you catch any intruders fast. Now, going further with securing human interactions, of course, we have heard the no passwords rule. In Microsoft, we take it very seriously. I don't think I have used my password in the last year or two. So for developer stations, we have moved to, of course, Windows Hello, meaning PIN biometric authentication. Anything outside the computer requires multi-factor authentication, or in the best case, YubiKey. To finely tune the access control for the resources, we started with assigning user accounts to specific roles for specific resources, but found that this was very cumbersome to manage. It led to situations where people left the team and they were the only administrator for some resource, right? So we moved to group-based authentication. We did some refactoring, so we have finely scoped groups based on the job requirements, based on the service, what you need to do. So it provides us with a relatively, well, I say single point of configuration, but it's a limited set of things you need to configure. And then when someone joins the team, it's very easy to give them access. And when someone leaves, of course, you can remove them. And to support that even further, we have automatic renewal, so we need to renew memberships periodically. That means nobody who has left the team anymore has access to our production services, nor even any other service, right? Then, going into the production access in general, we don't have any standing production access to modify anything. So, before we migrated on the bare metal machines, with some caveats, we were able to pretty much log onto the machines with our corporate accounts and do whatever. So in Azure, of course, that's no more the case. So we have, of course, read access for resources. You need to be able to tell what's going on. And a list access for secrets. So you don't need to see the contents of the secrets, but some metadata. So if you want to put something to use during the deployment time, code some references, then you can do that. for anything else, we try to have, first of all, no access required for basic debugging. We have logs, we have metrics, we have crash dumps automatically updated. If that is not enough, we have the kind of just-in-time elevation or break glass procedure in place, but that always requires a second-person approval. You cannot do anything on your own. So if your account gets compromised, at least the production is still safe. And that leaves an audit trail. So for us, that actually starts with the pull request itself. We have detailed logs about who approved the pull request, how did it go through build, how did it go through validation, testing, deployment, and up to the accesses and reads of production resources as well. So luckily, so far, we haven't been intruded, but if that were to happen, I'm quite confident we will be able to get to the root cause very fast. And finally, I would say the most learnings for me personally came from sunsetting the previous services. So what I can speak from experience, map out your dependents and what resources you need to remove before you actually start the work. For us in Microsoft, usually any decommissioning comes with a lot of legacy traffic. So you try to decommission something and you find that, oh, there are production users still depending on that, but you don't know who it is or why they're coming there. So for us, that's quite a big investigation usually. It takes several weeks to actually map out who's using it historically. So it takes time. And for us, we had a really bad experience with that because we started decommissioning a service, but it stalled. So we were already full on in the new service. We didn't pay much attention, and then it fell out of compliance, and then it fell out of security requirements. It didn't get updated anymore, but still it wasn't decommissioned fully. Luckily, we managed to remove it, so it's no longer a security threat. But I can safely say, don't start until you're ready to commit. Until you're ready to commit, put full effort into maintaining that. Another big surprise that we got was DNS records. Normal procedures usually you create some vanity URL FQDN for yourself, right? And then you create the CNAME mapping from this to your, let's say, Azure resources. For us, that could mean traffic managers, maybe load balancers. But the trouble is that these map to pretty much a string, right? And your resource FQDNs are generated based on the resource name and some well-known string that Azure appends to it. So whenever you create a key vault traffic manager, you will get something.trafficmanager.net, for example. And then when you remove that resource, luckily Microsoft bots are quite on top of their job. They snatch that resource immediately and they create the resource themselves. But if you just let it hang, then some malicious actor could just spin up a random subscription, create the resource with the same name, and just use your domain as a gateway to their code. So they could do anything. Even though they will not have the TLS certificate, they could still just perform a phishing attack and in the mail write, hey, we're having some certificate troubles, please fill in your password anyway. Yeah, and of course, when DNS records are cleared up, you have the option now to clean up every certificate, secret, service principal, any access that's given. And when you have cleared that, then everything else. So if you have a clear overview of those resources, I guess deleting those usually is quite trivial. So as a summary, rotate your secrets. They will get read, they will get leaked. So if you rotate them periodically, you minimize the risk. And if it's all automated, then you don't incur an additional cost for that. Automate everything. If you don't need to access your resources, if everything is automated, if you really don't need to do anything with those, first of all, it saves you time. Second, if you have an incident at 4 a.m., you don't need to use your brain cells to figure out if you're breaking something or not. Then minimize access from all angles. Reducing the attack surface, definitely the first basic steps of any security setup. Update your operating system and libraries. I guess that goes without saying. And clean up after yourself. If you don't leave trash, it cannot be used against you. So, questions?
So, do we have any questions? Please raise your hand. Okay.
Thank you for the talk, but I have a question. Are you using mostly Windows for this, running this stuff?
Yes, at this point, yes. We are moving to Linux-based containers as well, but that's a whole different migration.
So you're running Windows in containers?
Right now we're using Service Fabric, which is just virtual machines.
Thank you. And is it fun to automate that? It's PowerShell and stuff like that?
I don't really mind, actually. So I guess for hardcore Linux fans, I guess it might not be so pleasant. We have a guy in the team, but even he came around. I think you solve a problem, right? So in the end, you do what needs to be done. There's always a better way to do something. So I think at least recently Microsoft were quite receptive to this kind of feedback as well. If someone sees a truly better way, we can invest in that. And I, as an engineering manager, try to support that. But of course, if that's what you're given, that's the best thing that you can use right now, then I think even if you're fully on Linux, you will be able to automate things with PowerShell without much problems.
Yeah, thank you. I actually have a colleague who enjoys using PowerShell on Linux, and it's experience. Okay, thank you.
Okay.
Can you give some more details about how you deal with service-to-service authentication? Are you using any like Azure services for that, or like you have, I don't know, custom things?
Yeah, for us, not many things on that realm are custom. So our recent gain has been to using managed identities to communicate to Azure resources as well. So I'm not fully in the technical details about that, but what I understand is there's an identity generated for us and automatically updated on the machine, so we can just use that from the machine and we don't need to manage the things ourselves. I saw in the program there's some talk about managed identities, so if you're interested in that, please go see that and they will be able to tell you more.
Okay. More questions?
Have you had a security attack and what happened?
I don't think we have had a specific security attack aside from coming from within the company. As I said, the bots stole our domain, right? So that's a very good wake-up call that you need to know what you're doing a little bit better. So I think real security incidents, at least at this point, I am not aware of.
Okay. If nobody else has questions, then I have one. You mentioned the cleaning up after yourself. What about IP addresses? Do you give those back or keep them for not to be used as attack surface?
Yeah, for us, we're a bit of a special case because we're Microsoft. We're in many cases O365, which has advertised IP ranges, which I think right now for media, we have 2/14s of IPs that's reserved for Microsoft only, that's within the company. So for us, it's very easy. We can just release those IPs. It will go back to the pool. The pool is assigned to us, so if we redeploy, we'll get from the same pool. Deleting those ranges or reassigning them has not been an option so far, but I think we're slowly working on that. So in the end, maybe Microsoft has in general will possibly start to sell those. But that's up to the security teams to figure out.
Absolutely. In this case, let's give applause to Janno. And a little thank you from organizing team.